All right, guys, here we go. UH Quiz 6th edition. Let's turn off that guy because it's too loud. Thank you, thank you. All right, so today will probably be the only day that we do it like this, but I do want you guys to do it this way because I want you guys to be well vetted. Oh, you don't want to turn it off? Oh, it's 30-second countdown, right? Yeah. Guys, let's do it this way. Remember, to be differentiable, what does it mean? Let's begin before we even do anything. What does it mean to be differentiable? So if I have a curve, and you know what? Don't draw this curve here. Just draw it like up here. If I have a nice smooth curve, something like this, at every point between A and B, if I call this A and I call this B, at every point it's a nice smooth curve. Look, I have a tangent line everywhere. If I put like a point here, tangent line there, point there, tangent line there, point here, tangent line there. See? So that's differentiable everywhere. Now, if I have a curve something like this, let's see, I'm going to try and do, I'm going to do the same thing, and then I'm going to go, bam. Now, you don't have a tangent everywhere, because look, this is kind of like a corner there. Right at that corner from the left-hand side, it looks like it's this type of tangent slope. From the right-hand side, it looks like it's this type of tangent slope. So right at that moment, do you have a tangent? No. So you're not differentiable at corners. So if you have something like that, that's like a corner there. You're not differentiable at cusp. What's a cusp? Something like, I don't know, that kind of looks like a bird that you guys draw in art class, but, kind of like that, where I guess you can kind of see that you have a vertical tangent there, but, vertical tangents are not a thing. I mean, it's a thing, but it's not like, you're not differentiable. And if you have a vertical tangent, like we just said right now, but a vertical tangent, you can have it there. Yes, but what's the slope of a vertical line? No, don't say 0. No, don't say 1. Undefined. So that's why we say this is also undefined if you have a vertical tangent. Does that make sense? Now, if you're not even continuous, then forget it. Like if you're like, don't draw this, just listen. If you have something like this, you're not even continuous. So how are you going to be differentiable at A? You must be continuous to be differential. So if someone tells you that a function is differentiable, you're continuous during the entire domain. But if you're continuous, does that mean you're differentiable? No. Think of like the absolute value of x. The absolute value of x looks like this. It's continuous, but look, it has a corner. You're not differentiable at that corner. But if you're differentiable, you're definitely continuous. So one implies one, the other one does not imply. What is that? Like contrapositive, or okay, whatever. But you guys know what I mean, right? A implies B, but B does not imply A. If A, then B. If B, then A. Nope, that doesn't work. Okay, so we're good? All right, so here we go. Now we're into the good stuff. This is a question from UH. I don't remember what number it is. What number? Like number 9 or something? Number 9, I think, possibly, according to Kyle. Sorry, Kyle, that I shouted you out there. I'll delete. Okay. Determine the values of the constants B and C so that the function given below is differentiable. So you have something like this, guys. So first, you got to be continuous. So I'm going to go limit as x approaches from the 1 from the left-hand side of 3x. So if I approach from the left, I'm using 3x. Better equal the limit as x approaches 1 from the right-hand side of the bx plus c. So from that, equation number 1 is 3 times 1 equals b times 1 plus c. So 3 equals b plus c. That's equation number 1. Are we okay? Okay. Now, in order for me to, remember, I need to have a smooth transition. I already erased the graph. So the derivative from the left better equal the derivative from the right. So I'm right. Der from left. Der is just for derivative. It's just that sometimes in programs that you have, if you type in DER, it stands for derivative, so it automatically does it. Der from left must equal der from right. Now, I got lucky here with this example. Both are linear lines. Do you guys see that? What's the derivative from the left? Perfect. So limit as x approaches 1 from the left of 3 better equal. What's the derivative from the right? Yeah, b. Oh, okay. The left-hand side better equal the right-hand side. So from that one, equation 2, b equals what? B equals 3. There it is. If b equals 3, I plug that in here. 3 minus 3. So then that means c has to equal? What does c equal, Morales? No. 0. If b is 3, c has to be 0. Because b plus c has to equal 3. There it is. That's it. That's the answer. If you saw A, B, C, D, that answer would be in there, and you would click that one. Does that make sense, guys? All right. Same thing here. Same thing here. You must be continuous first. So I'm going to go limit. And I've noticed all these problems have a 1. I just noticed the 3 random quizzes, and they all had 1. So maybe that's part of their programming, that it's just 1 all the time. But let me know if you get something else. Limit as x approaches 1 from the left of 5x cubed better equal limit as x approaches 1 from the right of bx plus c. I'm plugging in a 1. Here's equation number 1. So this circle means equation 1. 5 times 1 cubed equals b times 1 plus c. And I know you guys are probably super smart and we're like, Chop, why are you doing that? Just say 5 equals b plus c. All right, chill. 5 equals b plus c. So there it is. Now I need to do the derivative. The right-hand side is simple. That's a linear expression, but the left-hand side is not a linear expression. It's 5x cubed. If you know Pascal's triangle, use it. If you don't know it, relax. So I need my derivative from the left-hand side. So here's what I need. What do I need? I'm going to be doing this. Limit as h approaches 0, f of x plus h minus f of x all over h. Do you want me to leave it in terms of x, or do you want me to plug in a 1 in there? 1 plus h. Okay. It doesn't matter to me. I'm going to go ahead and plug in a 1. I'm doing, see, this is what, you know what? I'm going to plug in an x. I'm going to plug in an x. Sorry. You can do it. You can do it, but it's just, if we're talking about h being a positive number, then it technically is like going to 1 plus a little bit past it. So we're on the right-hand side, and that kind of doesn't fit good with me. You know what I mean? So to avoid technicalities, and I guess since it says h approach 0, I guess you can approach also from the left, but we've been practicing where we're approaching from. Okay, so anyways, here we go. Sorry guys, here we go. F of x plus h is nothing more than 5 parentheses x plus h close it cubed, which let's break it down into something that you do know. 5 parentheses x plus h close it squared times x plus h. That's the same thing, no? Okay, let's do the x plus h squared really fast. We can do that one really fast. 5 parentheses x times x, x squared. X times h, xh, but I'm going to have 2 of them. And then h times h is h squared, and I still have x plus h here on the outside like that. Are we still okay? All right, here we go. Equal sign. I'm just going to distribute this. I'm going to distribute the x squared to both of those. So I'm going to write 5 parentheses x squared times x cubed plus x squared times h plus, I'm done with that one. I jump to the next one. 2xh times x, 2x squared h plus 2xh times h, 2xh squared. I'm done with that one. Let's go to the next one. H squared times x. Yep. Plus h squared times h. Perfect. And I still have that 5. Sorry, you don't have to do the sound effects. 5x cubed plus, okay, look. Before I distribute, I'm going to combine like terms there. And I'm going to combine like terms here. So that's 3x, well, I guess I already put the 5 there. So that's 3x squared h, right? 2x plus 1, or 2x squared x plus 1. That's a 1 in front of that. So what's 3 times 5? 15x squared h plus, and then again, this is another 3xh squared. So that's like a 1 right here, 2 plus 1. So what's 3 times 5? 15xh squared plus h cubed. Is anyone confused? Okay. Finally, so here we go. I'm going to write f prime of x equals limit as h approaches 0. Here's my f of x plus h. So I'm going to write 5x cubed plus 15x squared h plus 15x h squared plus h cubed. That's your f of x plus h minus, what's my f of x? 5x cubed. All over h. What's going to cancel out first? 5x cubed. Bam. Bam. What can I factor out next? an h. So here I am, limit as h approaches 0. Here's my h factored out, and I'm going to have 15x squared h. Oh, nope, that one's factored out. Plus 15xh, close it. Oh, plus h squared. Now close it, all over h. All right, what's going to cancel out? The h's. Bam! And then these right here are going to 0 because h is approaching 0. So all I have left, my derivative from the left is 15x squared. So here we go. Now we're ready for the whole derivative from the left equals derivative from the right. So derivative from the left equals derivative from the right at 1. So I'm going to write bullet limit as h approaches 0. No. We already did that. As x approaches 1 from the left, I'm doing derivatives of 15x squared. That's my derivative from the left. Better equal limit as x approaches 1 from the right. And my derivative from the right is just what? It's a linear line, so what's that derivative? Just b. Just b. Because that's my rate of change of that linear line. Does that make sense, guys? All right, so here we go. Equation, I guess, did I already write equation 1? Yeah. Equation 2. 15, parenthesis 1 squared, better equal b. That's my equation. I'm just getting from this limit right here. All right, so that means b equals 15. If b equals 15, plug it into what you have. So insert into 1. So here it is. I'm writing 5 equals 15 plus c minus 15 minus 15. C equals, I got a negative 10. So c is negative 10, b equals 15. Do you see what we did? Cool? All right, one last one. This is about as hard as it gets. Notice both of them are quadratic. So don't worry, we'll be fine. First, continuity, right? And no yawning, that's a demerit. Did you guys see her? She was like I'm going to say it. Oh. You looked like you were in defeat. I said like, oh, stop yawning, that's a demerit. And you went like this. You went. Okay. Yeah, I'm sorry, miss. I have the same jokes. I need to come up with new ones. What should be a good joke? Okay, let's continue this. All right. At x equals 1, I better be continuous. So here you go. Limit as x approaches 1 from the left of 6x squared better equal limit as x approaches 1 from the right of bx squared plus cx. So from that, equation number 1, 6 times 1 squared better equal b times 1 squared plus c times 1. So 6 equals b plus c. So far, so good. Now let's find the derivative from left. Der from left. Okay, der from left. I need f of x plus h. F of x plus h equals, wherever I have an x, I'm plugging in x plus h. 6 parenthesis x plus h close equals, oh, with a square on it. 6 parenthesis x times x times h, xh, but I'm going to have, so 2xh, h times h, distribute the 6, bam, bam, bam. 6x squared plus 12xh plus 6h squared. There it is. That's my derivative from the left. Well, that's not my derivative. That's just f of x plus h from the left. That's just f of x plus h. Here's my derivative from the left. F prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x. Here's my f of x. Here's my f of x plus h. 6x squared plus 12xh plus h squared minus my f of x, which is 6x squared. And all this is over h. What? Did I mess up somewhere? Oh, plus 6h squared, yes. I said it, but I didn't write it. Okay. All right, here we go. The 6x squared is 0 out. Bam, bam. And then what can I factor out? So limit, I still haven't evaluated, so keep writing limit as h approaches 0. H factored out, 12x plus 6h, close it, all over h. Okay, now what's going to happen to those h's? Cancel out, and h is approaching 0, so 6 times 0 is 0. So this just becomes 12x. So that's my derivative of 6x squared. Now let's do the right-hand side. Okay, let me change the color. From right. So I need f of x plus h for the right one. So b parenthesis x plus h, close it squared, plus c parenthesis h plus x plus h. I don't want to reverse order. X plus h, close it. All right, let's see what this is. Equals b parenthesis x times x times h. But I'm going to have two of them, so I'm going to write 2xh, and then h times h squared, plus, and then let's go ahead and distribute that c there. Cx plus ch. All right, let's distribute the b as well. Bam, bam, bam. So this is going to equal, let's see, bx squared plus 2bxh plus bh squared plus cx plus ch. All right, now I'm ready to find my derivative. F prime of x from the right equals limit as h approaches 0 of all this, bx squared plus 2bxh plus bh squared plus cx plus ch minus my original equation, which was parenthesis bx squared plus cx, close it. All this is over h. I'm going to distribute the negative. So let's see what cancels. I have a bx squared and a negative bx squared. Do those go away? Yes. Bam, bam. I have a positive cx and a negative cx when I distribute that negative. Do those go away? Yes. Bam, bam. All right. Does everything have an h on it? Yep. So here it is. I'm going to factor out an h. Limit as h approaches 0, factoring out an h. Let's see, what do I have? 2bx plus bh plus c, close it, all over h. All right, what cancels? Or what cancels? The h's. And then h is approaching 0, right? So this guy is going to go to 0, and you're just left with 2bx plus c. You can probably have figured out that this was going to be c because that's a linear term. But, now you got that 2bx there. Are we okay, guys? All right, here we go. You're going to set the derivatives equal to each other at 1. I'm going to go back to red. That seems to be my neutral color here, guys. So limit as x approaches 1 from the left of my derivative from the left, which is 12x, equals limit as h approaches 1, x, as x approaches 1 from the right of 2bx plus c. All right, let's plug in a 1. So equation number 2. 12 times 1 equals 2b times 1 plus c. So 12 equals 2b plus c. I'm going to solve for c because c is by itself already. So I'm just going to move the 2b to the left there. And I'm going to write, I guess I'll write it like this first. 12 minus 2b equals c, and I like to write it like this. C equals 12 minus 2b. What happened? Tell me.
Why didn't you just use elimination with the other equation?
Oh, yeah. Let's do that. It still would have worked like this, but I like your route better. All right, equation 1. I'm going to write 6 or b plus c equals 6. B plus c equals 6. Equation 2, I'm going to write 2b plus c equals 12. And what do I got to do to get rid of the c there? Subtract them? If I subtract them, 1 minus 2b is a negative b. So negative b, the c's cancel out, equals 6 minus 12 is a negative 6. So that means b equals 6. As soon as I know that b equals 6, Oh, well, b plus c has to equal 6, so that means the other one has to equal 0. There it is. How do we feel, guys? All right. Tomorrow we will learn a shortcut. Don't look at Khan Academy, at least not yet. Don't go to Google. But try this one out for now like this. And we're done, guys. That's a bunny.